My name is Natalia Stakhanova. I'm professor and New Brunswick Innovation Research Chair in Cybersecurity at the University of New Brunswick, not far away from here. We are actually in Fredericton, so it took me a couple of hours to get here, but I'm glad I see all of you here. I'm coming from academia, so the talk might be slightly different from what you've seen here in other tracks or even in this track before. So I'll be happy to answer any of the questions if some of the things might seem perhaps not clear. I try to make it interesting to you rather than technical, so go ahead and ask me the technical stuff. I'll be happy to dive into that as well. All right, ready? All right, so know your enemy, malware, authorship attribution. This is my passion. This is what I do at my free time when we are not working with industry. Industry research is extremely interesting to us, but there's a lot of topics that we would like to explore and have freedom to explore as academics. I'm sure a lot of you heard about Art of War by Mao Zedong. Have you perhaps you even read the book? Have you heard about the book? Okay, some of you have heard about the book, some of you have read the book. It's full of quotes, right? It's a really good book, and a lot of it actually applies to what we do in security. And if you think about malware analysis, intrusion detection, that's pretty much what's written in the book. And one of the quotes that he uses, and I like a lot, is know your enemy, know yourself, you will be able to fight hundreds of battles. And this is what we have. If you think about malware analysis and intrusion detection, we know ourselves, right? We think we know our defenses, we know the perimeter, we know what we need. Now, we think that we know the enemy, but do we? That's the biggest question that actually bothers me. And if you look at the statistics, especially the latest statistics, this is the latest statistics for the malware analysis. So the samples are new. So we're not even talking about the we're not even talking about the duplicative samples. This is novel malware samples that end up in database. And as you can see, in the past couple of years, they've been raising rapidly, and 2018 is not here yet, but I'm pretty sure we're going to see another spike in 2018. And if you look at this picture, there's certainly something wrong with it. And I hope you agree with me. And especially from my perspective, being in academia and working with this all brilliant scientists and being able to develop wonderful, we think, wonderful, very efficient approaches to fight malware, and then we come into something like this, and it clearly shows that we're doing something wrong. We're missing the point somewhere. We shouldn't be. If we're doing everything as we think we do, that's not the picture we should be seeing, right? So there's clearly something wrong here. We clearly don't know who we're fighting. We don't know who the enemy is. Now, this is I pulled it out from January 2018. This is actually Endwine, picture of Endwine malware. It's spreading again. This time, it's primarily affecting the aerospace industry. This is new. So it's been in the news for a while. It's another spike. People have been talking about this as a new functionality, something that we haven't seen before. And now, if you, for those of you who've been around for quite a while, you probably remember that Endwine is not new. We've heard about Endwine last year. It's actually a Trojan ransomware. It's not ransomware. It's a Trojan remote administration tool. So it's been around under different names, and every single time when it comes up, there's another report coming out. Oh, look, we just found, it has this functionality, and then, oh, we don't need to assign the new name to this. We've seen it before under a completely different name. So if you go back and look at the history, it actually dates back to 2012. 2012. We are now in 2018. right? At that time, it was called Frugus. And if you look at this timeline, it actually changed the names a couple of times. And the name changing, you probably realize we, as analysts, when we get a new piece, new sample, after analysis, we assign the name, unless we know what it is. So the fact that we keep changing the names means that every time we look at it, we actually don't think it's old malware. We think it's something new. But again, looking at this timeline, there's definitely something wrong with the way we treat malware analysis and malware detection, at least from our perspective. None of the techniques we've developed so far seem to work, at least not to the satisfaction, not to my satisfaction. So, wouldn't it be wonderful to actually have something like an Oracle box? A moment you get infected, the Oracle box tells you, what happened, where it's going, what you need to do, what the functionality of the malware is, where is it coming, and the best of the best is who is behind it. Wouldn't it be great that the moment you put it in, 5-minute analysis, maybe 10-minute analysis, and you actually get the name of the person and the address that you can send to the law enforcement. I know, that's my dream. This is what I hopefully in the future we'll be able to actually have it, and I'm really hoping to be a part of it. This is what I'm interested in, and this is where my research focuses. If you think about the endpoint, actually looking at the identity of the person who is behind it, we are looking at the field known as authorship attribution. It gives a lot of interesting insight into the person's sort of style. But if you think about authorship attribution and you think I've never heard about this in my lifetime, you're probably right. It's actually well known in the literary domain. It's not that much known in computer science or engineering domain. The domain itself, the field itself, authorship attribution or stylometry, a lot of people call it stylometry. It's just a set of techniques that tries to identify the person's style, writing style, based on the unique characteristics that can be derived from his books. So think you're writing something, write a note, you write that in a certain way, use certain phrases. So those phrases will sort of create a pattern that can be very characteristic of your writing style. So it sort of makes sense, right? We all have those unique styles, not just in writing, but in life. We all have habits. We like certain parking spots. We like certain seats. We like certain things. We like our breakfast in a certain way, right? So we have those patterns. So it does make sense. We have them in writing. We have them in the way we live. So why don't we take that style and sort of apply this to new domain, something that we do in computer science? So think about writing software, right? It's not that unusual, right? You might think, yeah, there are probably some parallels here, and this is what we've been looking at, been trying to do. Now, I don't know if you know, but in the literary domain, this is actually a very popular technique, and a lot of people have been looking into using it in a practical way. The field itself dates to the 19th century. I believe that was the first attempt to actually use the stylometry to identify the authorship, and that was on Shakespeare's poems. Okay, do I have some notes here? You've heard about that, or that's okay? Perfect. All right. So, do you know that the debate is still going on? Once in a while, we still see people who come up with this crazy ideas that wasn't actually him. Let's do it again. Let's check. Whoever have done it before, they didn't know what they were doing, so let's do it again. I have a better technique. So every time they confirm the authorship of his poem, so it's sort of going on, and I'm sure in the next couple of years there will be another question coming up. Who wrote that? Maybe there was someone else helping him. Now, the most recent case, I think this is probably the closest to us. And maybe the closest to your hearts. From those of you who are a bit younger, maybe have kids, Harry Potter series. heard about it? Okay, perfect. So the author J.K. Rowling, she's sort of known for her Harry Potter series, right? But she's also a bestseller author for criminal novels. And the interesting thing is that was discovered just recently through the authorship attribution. In 2012, the poem came out, was called The Cuckoo Egg Calling, I think. It was written by Robert Galbraith. And that was his first poem, and the poem became #1 bestseller pretty much overnight. And people became jealous. You know, we all are, right? And they became very suspicious. How come this person who'd never written anything? And he himself described his past as military past. He was saying, you know, this is my first attempt to write anything. And his first attempt suddenly became a bestseller. So people didn't believe him. Of course, nobody ever seen him in person. So they started questioning where this is coming from. And the one journalist from a newspaper said, you know what, I've got a hint. I think I know this is her who wrote this. Let's check it out. And the only way to really figure it out was applying authorship attribution. Well, other than actually interrogating her, that was a nice way to do it. So they went to a research group in Pennsylvania and asked the professor who was running this group to help them out, which he actually did. And he confirmed the authorship. So that was actually written by her. She was very upset. She came out and did the press conference right after that, saying, yes, it's indeed me. But the fact that it came out, it was not intended, and she wanted to keep that secret. So that's sort of a perfect example of how we can apply attribution, right? Think about the same thing, what we can do with this type of techniques and with these ideas in security. You have malware, you have, well, it doesn't matter, you have any kind of compromise, you've got traces. If we can apply the attribution and have an understanding who's done it, that's a dream come true for us, for me at least. So this is what I'm trying to do. Obviously we have a number of challenges, right? It's not a traditional domain. So the first challenge we have is the fact that we actually don't have a source code, right? So if you go back to the literary domain and how it's normally done, you have your novel and you break it down into sentences and paragraphs, and you look at the lengths of sentences and you say, well, it looks like this author is using, you know, short sentences and likes these certain phrases. And his vocabulary is very rich. Now go back to the source code. We don't have short and long sentences. We don't have rich vocabulary. We have a completely different type of context that we're dealing with. So the nature itself is really challenging. We can just take those techniques and apply them directly, even though the idea is nice. Now, the second challenge is the fact that we actually, a lot of the times, we actually don't even have the source code, right? Malware is a perfect example. How many malware writers do you know that's going to be willing to give you source code? You got compromised? Hey, I've got the source code for you to analyze. Doesn't happen, right? You're lucky if you've got binary. That's perfect. A lot of the cases you don't have that. You've got some traces. So that's a challenge. What are you going to be analyzing? What are you going to be attributing? This is vague. It becomes even more vague, right? Now, the binary code itself. Now, the source code has a lot of personal information, right? The perfect example, comments. You've got your comments. Yeah, you've heard about the name. You've heard about the case a couple of years ago with two teenagers from Israel. They were writing malware and actually left their names with address in the comments in the source code. It was wonderful. They got apprehended right away, but it doesn't happen very often. And I think that was the only time when it actually happened. So the personal information retained in the source code is actually lost through the compilation process, right? When we end up with the binary, we don't have any of those personal characteristics anymore. So even if you have a binary, a lot of the personal stuff is lost. what are you going to be attributing? Think about all the libraries you're touching, all the as you're writing your code, all the SDK stuff that's being put as a part of the code. It's not yours anymore, right? Through the compilation, what are you attributing? That's a huge challenge. Now, finally, the obfuscation. Most of the stuff that we see is obfuscated. The obfuscation aims to disguise the appearance of the code, right? It doesn't change the functionality. Functionality is still the same. So think of it as putting something in the box. Yeah, it looks different, but it's still the same, right? Nothing changes. So that's what the obfuscation does. Like I said, we still, this time, we see, doesn't matter what field we're talking about, malware, the mobile or traditional, we still see a lot of obfuscation. Maybe it's not the most sophisticated obfuscation, but it's there. So we're dealing with that. There are different types of obfuscation that sort of exist in the field. The layered obfuscation is the easiest one. This is pretty much a basic layout changes, adding some comments, removing comments, adding spaces, moving stuff to another line. Really basic stuff. The data obfuscation is actually change the data structures being used. So say you're using arrays, you would break them down into 2 data structures. Okay, very good, a bit more sophisticated because you have to go through, it's not simplistic, you have to change the control flow as well, but very good obfuscation. Control obfuscation, you actually modify how the program runs. Probably one of the most advanced obfuscation types I've seen. And finally, the preventative obfuscation. How do we analyze the malware? Use the tools, right? So what if we put instruction to make those tools not run? That's perfect, right? You don't need to worry about anything else. Just they're gonna break right in the beginning. Forget about everything else. So that's one of the types of obfuscation. You just don't let them run, period, right? So all these types of obfuscation are possible, and each of them sort of affiliated with different level of complexity. The layout, like I said, is the simplest one to recognize for us, but it's still there, right? It's one of those challenges. Even if you end up with the binary code and it does have a little bit of your personal style, you have obfuscation on top of it. So what are you gonna do? So we're actually battling against those challenges. But if benefits are great, if we're able to solve those problems, then the benefits are certainly going to pay off. First of all, we're going to be able to understand what we're dealing with much better, right? Clearly, the malware classification will be more effective, not what it is right now, hopefully more unified. We'll be able to track as malware evolves, and just in the case of N-Wine, we will be able to see because every time the sample would come out, it would come out with additional functionality and additional complexity. So it would be really nice to be able to track it and also not have a scattered functionality. Now, we will be able to build malware author profiles, which is probably very beneficial for the law enforcement. But even for us, being able to understand who is behind all these attacks that keep happening is very useful. The detection itself, we don't think about detection being involved in the attribution, but think about this. Right now, all your detections are based on signatures, right? Now, even if you represent a company and you say, well, no, I have this AI engine that runs on the cloud and it's awesome. From what I've seen, yes, it is, but for the marketing purposes, right? It's still, at the end of the day, you still rely heavily on the signatures. So really, you're just as good as your signatures. And the signature, what I'm referring to, is the real short rule that describes the malware sample that you're dealing with. So every time you see malware, you need to develop that signature, that rule that will say, this is what you're looking for. Look for it next time, right? So if you don't have a signature, you can't catch malware, right? So think about this. If you have malware profiles, malware author profiles, and we know their style, and we know how they write malware, the next binary you see, you really don't need to think about whether it's what it is. All you have to do is to see where it's coming from. If it's coming from a person who is known to write malware only, here you go. That's it, right? The end of the game right here. So we'll be able to actually be a bit more proactive than we are right now. That will be, in the long run, that will be huge for us. And finally, we'll have much better prediction. So if we have the malware, if we're able to have the profiles from malware authors, if we're able to track the evolution of malware, what we can also do, we can analyze the tactics, the strategies. We're also able to prepare ourselves. So the next time you hit with a malware attack, you know right away what to do. You know what's going to be the best, right? So hopefully all these benefits are very attractive to you and convince you that there's a lot that we can do here. Now, the attribution spectrum is actually quite broad, even though I keep talking about the binary and the source code. Those obviously are our best chances. But you do have other potential vectors that you can use for attribution. So the network activity, that has a lot of personal, or I guess, developer information. The target characteristics, how they've been selected, why they've been infected, installations, infections, even the communication protocols, right? All that stuff together describes not the victim, actually the person who is behind it, right? Or the group of people who are behind it. So the interesting part is we've looked at all the components. We've looked at the source code attribution and the binary code attribution, and this is what I'm going to talk about briefly today. So the source code attribution been done by a few people. Interestingly enough, whenever it comes to the attribution of source code, people say, well, we either do programming assignments, right? We take students and look at their programming assignments and see, how they did, whether we can detect any attribution, right? If we can attribute any of the students and detect plagiarism. But if you think about those programming assignments, how representative they are of the real life, of the real code? Not much, right? Usually, the students start writing the code, 2 hours before the deadline, right? So is it actually representative of their coding style? What do they have to do to make it to a deadline? They start copying heavily, right? And I'm not necessarily talking about copying someone else, but it can be their own programs that they've written in the past, but it doesn't matter, right? So there is a lot of this sort of personal use that is happening. So when you look at their programs, well, yes, they do have written somewhere, but can we sort of count on them being the perfect examples of real life situations? Probably not. Now, if you look at the so what we've tried to do is actually create a couple of different data sets, and one of the probably most representative is coming from the GitHub. So that's the community of the open source community of developers. So that, to me, is a bit more representative of the code that we will be seeing on a regular basis. And we re-implemented a few things and tried to see if we're going to get the same results that the authors are getting on their programming assignments with a bit more realistic situation. And probably not surprising, we weren't able to get the same numbers. So as I have here, one of the works that was published recently in this field, 2015, claimed 96%, 96.8% accuracy, meaning that pretty much 100% they can attribute person to an assignment. So this is very high, right? Very high. Now, we weren't able to get the same. Now, we got the same on the Google Code Gem data, 99%. So the Google Code Gem is, I don't know if you're familiar, it's actually very similar to the programming assignments. It's an open competition for developers. You're given timeline and you're supposed to solve a problem in a very short period of time. A problem is prescribed, obviously. You can do whatever you want, and typically the solution is very short. So again, how representative is that of the assignment? But we thought it still doesn't matter. It's still good for us, right, for the analysis. And the GitHub obviously is completely different. So we look at different types of programs. We had roughly 30% from education, games, and 30% of different development type. 63% overall. So we're getting better, right? It's a bit more realistic. So this is what you're able to get with the attribution in real life today. Now, if you look further, you will see the layout features, lexical features, and the syntactic features. So that's a breakdown based on the type of features we can use. So the layout features, this is the comments, the spaces that you can change in the code. So what if we only use those features for attribution? How good is the result? Not very good, right? Less than 1%. If this is what you're going to be relying on, then you're not going to be able to attribute much, which is good. I think it's a good news for us, right? Now, the lexical features. The lexical features is a bit beyond that, right? So this is what students do when they copy each other. Change variable names, right? You change a variable name, that's it. Now it's yours, right? It doesn't look like anyone else's. Perfect. So can you use that? Yeah, we can use that. We got a 38% on the GitHub data. So we can still attribute, but that's not enough. And finally, the syntactic features. The syntactic features, we go into AST tree, right? So this is more into the actual flow. With AST, you're able to get 61%. So what it tells us that you really, when you're looking at the attribution, you really need to look at different levels. And as expected, certain levels are not as good for attribution as others. Now, right here, we did a little bit more analysis of what we're dealing with, and just to understand how the code is being reused. And as you can see, it's percentage of plagiarism. So that's what I was referring to when I was saying the reuse, code reuse, right? So people heavily reuse code. That's one of the reasons why when you're looking at academic studies, you have this wonderful 100% results, right? And then when you go to real life, somehow it's not 100 anymore. And you look at the results and you question what's going on in between. That's what's going on, right? So whenever we do it in academia, it turns out even the data sets that we're using, they heavily reused. And I mean, clearly, you just so basically trying to attribute repeated stuff, which is easy, right? You see the same thing 500 times, of course you're able to attribute it. Now, in the GitHub, this is not surprising. It's only 11.7.8% of code reuse, which is quite realistic, right? We do reuse some of the code, that's normal. We actually encourage to do that. But it's not 63%, right? It's much, much less. So that's what contributes to the attribution level. Now, still, the encouraging thing is we're able to do it even with the little reuse, we're still able to do it at 63%. So we can still find you. Now, source code, like I said, it's wonderful, but we don't have source code in a lot of situations. So can we actually do it in the binary? So we looked at the mobile code, and specifically we've been working with the Android code for this project. And one of the things we decided to look at is the data analysis, data structures analysis. So if you remember the different type of obfuscations, one of the obfuscation types is a data structure obfuscation. It's fairly difficult because it's difficult to do, right? And a lot of people try to avoid it. Now, why are we even looking at the data structures? If you're writing your code, think about, or you've written code before, think about the data structures you prefer. Is it array, hash map, linked list? You always tend to stay with something that you like, right? And it applies to data structures a lot. And interestingly enough, people are very difficult, very resistant to change their habits. So if you stay with your data structure, it doesn't matter. Unless somebody is going to come with a gun to you, you will try to use what you like, right? So that's why the data structure. So what we looked at, we actually extracted all features that would relate to data structures, not just the opcodes, the bytecodes, everything that would be associated, the actual content, the size of the data structure, the type you initialize, all that. So on the side, you see the Smalley code for a small array that would be sort of declared in the Android code. So basically extracting those features, it's a fairly large set of features, but it describes what would you use in the code and how would you use it in the code. We decided to actually go beyond just looking at whether we're able to attribute this particular binary to you, but we wanted to see whether we can go to the wild, to the marketplaces, and attribute things on the marketplaces. The way we decided to do it, we decided to proceed with two-level analysis. The first one is we've sort of created a fairly small set of profiles for the authors. The authors were selected manually and confirmed. Well, we don't know the authors. We just collected the information and confirmed that those are the actual people and all the data belongs to them. And we created something called benchmark profiles. So once we had the benchmark profiles, then we went into the markets, Google Play Market to be specific, and created profiles incrementally. What it meant is we actually crawled the markets and tried to attribute the profiles, or not the profiles, the binaries, to either the profiles we've created before, the benchmark profiles, or to see if we can create new profiles out of the apps that we've seen. Now, if we're able to do that, that's perfect. If not, then we would sort of keep the app for the future and see maybe in the future we would have something else that would resemble this particular app, and we'll be able to attribute and maybe create a profile. So that was kind of interesting for us to look at. So this is some of the results. We used two data sets. We created the legitimate data for the benchmark profiles. We had a data set of legitimate authors. So those were checked through VirusTotal to make sure they are actually, all the apps produced are legitimate. And then we also created a small set for the malicious authors of 10 people. Overall, 222 apps, again, confirmed being malicious. So we just wanted to see whether attribution would vary between the legitimate and malicious authors. Now, like I said, the number of features varied drastically. So one of the problems we ended up right away is the scalability, right? Do you want to have more features and obviously be a bit more granular in your analysis? Or you want to have less features and then sort of be a bit more efficient. Right, it's hard to see that. I think it's in bold right here. So we will be able to stay with roughly 2,000 features per profile. That gave us roughly 97.7% accuracy. So we decided to go with that. It's drastically less. It's like if you look at some of them, we have close to 200,000 features. That's a lot. And the accuracy is just slightly better, so it doesn't worth it. I think we've been convinced that we sort of can trade efficiency for accuracy in this case. Now, down below you see the results for both legitimate and malicious authors. We, for analysis, to be able to analyze the results, we've created 3 metrics, but the important ones are the AA, the number of apps attributed, and the CA, the number of apps that were correctly attributed, right? So you want to see it both, and obviously you want to have 100% of both, obviously, right? You want to be able to attribute everything, and you want to be able to attribute everything correctly. Never happens. So as you can see, a legitimate author data set, we're able to get roughly 80% attribution with 97% being correctly. And then malicious authors, 75, slightly lower, but still fairly good, 77% were attributed correctly. So we knew who the authors are, we knew what the apps are, so that was our validation. We want to make sure once we go into the market and start crawling the market, we'll actually be reasonably sure that the results we're getting make sense. So we went to the market, and this is what we got. We had a few data sets that were collected earlier for different purposes. So we had a set of just adware, we had a set of ransomware, AppDroid, and then finally the markets and the Google Play. Sort of those we assumed would be completely, clean, right? So the way we started doing it, obviously from the top, we first process and see if we can attribute any of the malicious apps to the profiles that we currently have. And of course, we didn't expect any of the malicious ones to be attributed to the benchmark profiles, the legitimate benchmark profiles, so that was good. We had a completely different situation with the legitimate data, which was interesting. But if you look at the number of apps that were attributed, they sort of vary depending on the set. And the same thing with the correctness. The correctness was fairly high for those that were attributed. So I guess the question is, once we attribute it, we can be reasonably sure that we're doing it correctly. Now, on the Google Play and the markets data set, the markets data set about roughly 8 data sets from different countries. The attribution rate is very low. Well, the markets are huge. The markets are huge. So I was happy to see that we're able to get even 30% of them. But what was interesting is we started seeing that the apps coming from the markets started being attributed to the malicious data sets. Not the legitimate ones, right? So the official rate on the Google Play is 1.2. That's the malware rate on the Google Play market. But we started seeing the actual attribution to the malicious profiles, which to me means we are on the right path, right? So if we can keep it up, this is where we're going. I have a lot that I wanted to talk to you about, but unfortunately I'm seeing the numbers. I only have a few minutes left, so I'd rather talk to you and answer your questions other than keep going with my numbers. In any case, we've done a lot of different things. We can attribute a lot. We can attribute the tool chain. We can attribute the obfuscation. We can attribute different packers being used. So we can really attribute a lot. Now, this is still just the beginning. There's a lot to do. So don't think that the job is done. We have a lot of things to do. But I'm really happy that you can run, but you can hide, but you cannot hide. There's a huge hope for us. We can still catch you. Thank you very much.